All right, so 6, 6 talks about this, and I'm okay. If I had 2 to the x equals 2 to the third, what would x have to be?
3.
Right, and what I think you're saying, Kelly, is listen, if you take 2 to some power and you take 2 to the third, and these two things are supposed to be equal, then you have to take 2 to the third over here because they're the same base. So whatever you take this to, 2 to the third, this would have to be 2 to the third as well. So x equals 3. Now, the math behind it, not the logic behind it, is technically what you were doing is you're saying, you know what, I'm going to log base 2 to this side. And what did we talk about when you have a base here and this same number right here? What did these two basically do to each other?
They cancel out.
And then if you do it to one side, you have to do it to the other. And then over here, you have the same scenario happening. So these cancel out. And basically, that's what you're doing. So I don't need to see the written in there. Actually, I'm okay with you just saying, hey, if I have the same base, I know that the exponents have to be equal. But I need you to even do that if I gave you something like this, right? Well, that means that I have the same bases. That means that x plus 3 has to be equivalent to 4. And then you just use your algebra skills to solve this. And technically, you should take this like we have in the past and plug it back in and check it. And that becomes 2 to the 4th. And yes, 2 to the 4th is going to equal 2 to the 4th. So check. I know that I got that right. Now, how can they make this a little more tricky? What's the problem? What's the difference from this one that I showed you and the just a couple seconds ago one that I showed you? What's the difference? What's the difference from this?
The base is different.
Yeah, from here, I gave you both bases were 2. When I wrote this one, both bases aren't 2. So we got to learn how to deal with that. Now, I want you to try to tell me something. What do you think we could do to make them so? I want to make this and this be the same base. What's something we could do to it?
Find a common multiple, or at least common, least common multiple.
Do you mean like try to make this? Well, let me tell you something we can't do. Can we multiply this side by a number to make it become a 4? Well, that's what some period said. Well, if I tried to times this by 8, first off, there's two things that are wrong. If I times this by 8, you can't actually multiply the 8 times the 1/2 first, because the order of operations says I must take care of this exponent first. So I'd actually have to raise the 1/2 to the x plus 7 first, then I could multiply the 8. So I can't come in here and multiply this by 8. The other reason it's wrong is if I could do that, I would times this by 8. You would have to times this side by 8, and then this no longer would be a 4, so they wouldn't be the same base again if that was possible, which it's not. So there's two reasons why that wouldn't work. Does everybody understand what I just said there? Thumbs up. All right, so what I could do though is, what if I can change the way this looks? Or what if I could change the way this looks so that they both come to the same number? So I'm not going to multiply by anything. I'm not going to divide by anything. I'm literally going to keep this same number. I'm just going to change the way it looks. Kind of like when you had a half and you would take the 1/2 out and you put a 2/4 in. You didn't do anything to both sides or anything like that. You just substituted an equivalent number in because it made your life easier. Like if you're adding 1/2 plus 1/4, what you did is you said, I don't want this one. You get out of here. You can come in its place because you are the same value. And now I can add these two fractions together, right? You didn't change anything about that. You didn't multiply both sides by anything, or there was nothing like that. That is, a possibility, but that's not what we're doing for this one. How could I change the 1/2? All right, let's change the 4th. Let's change the 4 first. Maybe that'll be easier. What number could we change the 4 to?
8/2.
That won't help us. Remember, we're trying to think of it like this, Orist. We need this to be 2 to some power, or even 3 to some power. We need this to happen. We have the same base, and then they have exponents, because then I can make the exponents. That's our goal. How can we make these both have the same base? What could we change 4 to? I didn't hear you, Orist, if you said something.
One half.
Is 1/2 equal to 4?
No, change 4 to 1/2. Can you do that?
No.
Oh.
Is one what I'm asking you is, can you just take the 1/2 or can you take a 4 out and put a 1/2 in its place? No, they're not the same. What is the same thing as 4 but just looks different? And it has a base.
8/2.
2 to the 2nd.
Oh, there we go. What is 2 to the 2nd? What does 2 to the 2nd equal, guys?
4.
Does it have a base? Does it start getting the shape that I told you, where we're trying to get like 2 to some power equaling 2 to some power? Do you get what I mean by that?
Yes.
So 2 to the 2nd, what is that replacing? Okay, and then what else do I have on that same side? It wasn't just a 4, it was 4 to the
3x.
So I need 2 to the 2nd to the 3x. I have done nothing to that side. That is the same exact thing. The only thing I did was I changed the way the 4 looked. I made it 2 squared. Do the same thing here. What could you do to a 1/2? What can we do to a 1/2 to maybe make it to where it's 2 to some power?
2 to the -1 power.
Yes, 2 to the -1. That replaces only this part. What do I still have left? 2 to the -1 to the x plus 7. Does everybody understand? This right here replaces only the 1/2. The x plus 7 is still there. The 2 squared replaces the 4, but I still have to the 3x. So I really have the same exact thing. I've just changed the way it looks, which is what I kind of call math magic. And the reason for doing this is because now, what happens when you have power to a power? This is an old rule from Algebra 1. What do you do with the 2 powers?
They multiply.
So what is -1 times x plus 7? It turns into
Negative
x
minus 7.
Yes, equals 2 to the power to a power. You multiply them, 6x. Now look at what we have. Now we're cooking. Now we've got a 2 base. I know that now -x minus 7 has to equal 6x. And now I can use my regular algebra 1. Add x, negative 7, don't forget to drop the negative with it, equals 7x, divide by 7, divide by 7, x equals negative 1. And then yes, what we've done in the past, you should still do, plug it in and make sure it works. 1/2 to the negative 1 plus 7, does that equal 4 to the 3 times negative 1? This turns into a 6, so this is 1/2 to the 6th power. 1/2 to the 6th power is really 1/2 times 1/2 times 1/2, or 1 times itself 6 times is 1, over 2 times itself 6 times is 64, and that equals, what happens here? This really turns into 4 to the negative 3rd. The negative kicks the 4 down to the denominator. That turns into 4 to the 3rd. 4 to the 3rd is 64. So I get 1 over 64 equals 1 over 64. Check. I know that negative 1 equals x. Thumbs up if that makes sense. All right. So the next types of questions is this is all we're doing is kind of the same thing, getting this idea. Now this isn't the only way to solve these. This only works if what can happen. When does this only work? If I can make this what?
Have the same, like when you can have the same base.
Right, and this one works, right? Because I can rewrite this as 5 to the 2nd to the 3x, and I can rewrite, and it's nice to know my multiplication tables, I can rewrite this as 5 to the 3rd x plus 2, right? If I had like 4 to the x equals 9 to the 3rd power, am I going to be able to solve it by the way that I just showed you? No, because I can rewrite this as 2 to the 2nd to the x, but over here I can rewrite this only as 3 to the 2nd to the 3rd. That's no good for me. This is a 2, this is a 3. They're not the same base, so that would be pointless for what I'm trying to do. You have to be able to write it as the same. So it's only really in special cases can you do this. So it's got to be the same. These numbers got to be special to be able to write them as the same base. Same base, power to a power. So I can go, this becomes 5 to the 6x equals 5 to the 3x plus 6. Got the same base. I can make these two equal. 6x equals 3x plus 6 minus 3 minus 3. 3x equals 6. Divide by 3. X equals 2. And then yes, you should go back and plug it in up here into the OG and make sure that it works. Another example. And then tomorrow we will practice this and some other ways of doing this when this doesn't work. Right here, you should be able to see, this is like kind of like scientific notation. You can rewrite this as doom, doom, doom. If you move that right there, that's the same thing as 10 to the negative 3rd. And now I have it both written as something to the 10th power, or 10 to the something power. And so I can go negative 3 equals 6x, divide by 6, divide by 6, negative 1/2 equals x. So it's all about making them have the same base, and then you can set the exponents equal to each other. But again, this only happens in special cases. Tomorrow we'll show you some of the things when it doesn't have that. You can't do this to it. Does anyone have questions?